Welcome to the deep dive. We're going way past just 3D printing little plastic toys and stuff. We're going to dive into some serious research.
It's amazing how far 3D printing has come.
Yeah.
It used to be this niche thing, and now it's like changing how we think about design and making stuff in so many areas.
Totally. We've got research here on making super strong plastics, like insanely strong, even tougher than they already are. We've got 3D printing for car engines, so they're better for the environment. And get this, even using 3D printing to fix up old historic buildings.
Yeah. It's really cool to see how all these research papers show that 3D printing can be used for like actual real-world problems, not just for making prototypes and stuff.
Okay, so let's start with this paper on making PLA plastic even stronger, and they do that by adding graphene.
Graphene.
Yeah, graphene. I know you're probably thinking graphene again. But this is really cool. So they looked at, like, when you 3D print PLA into these plates, how adding graphene changes how strong it is and how it breaks.
Right, and PLA is already pretty popular for 3D printing because it's biodegradable and it's strong. But when they added graphene, they could make it hold like way more weight before it breaks so it can handle way more stress.
Whoa, that's a big deal. Imagine 3D printing parts for drones or medical stuff using this super PLA. It would be lightweight and biodegradable, like regular plastic, but strong enough to handle, really tough jobs.
Exactly. Even a tiny bit of graphene made a huge difference.
Really?
Yeah, they 3D printed these plates with notches in them, you know, to mimic like real-world stress points.
Ah, I see.
And the plates with the graphene, they could handle way heavier loads before they broke.
So this could mean using PLA for things we never thought possible.
Yeah, it opens up so many possibilities.
That makes me wonder if they could use this stuff to 3D print car parts, make them super strong.
Speaking of cars, we have this other study about using 3D printing to make a car engine that's, more eco-friendly.
Oh yeah, that was interesting.
Yeah.
They looked at this crucial engine part called a rocker arm.
It's usually made from this really strong forged steel.
Gotcha.
And they wanted to try 3D printing it using a different alloy, 17-4pH stainless steel, because it's better for 3D printing.
But wouldn't that change how the part works? I mean, car engines go through a lot of stress. How they make sure a 3D printed part could handle that?
That's where it gets really cool. They tested out different heat treatments, like really carefully, to get the structure of the 3D printed steel just right.
So like they baked it in a special way?
Kinda. By controlling the heating and cooling, they could get the 3D printed part to be just as strong and tough as the one made from traditional forged steel.
Wow, so they like fine-tuned the 3D printed steel to be just as good as the original. Did they actually put this 3D printed rocker arm in a real engine to see if it worked?
They did, yeah. They ran simulations first, virtually, and then they did real-world tests in an actual engine.
So they didn't just like rely on theory, they actually saw it in action.
Exactly. Shows how powerful 3D printing can be for making, really high-performance parts.
It's kind of crazy to think that someday car engines could be more efficient and maybe even cheaper to make, all thanks to 3D printing.
The possibilities are pretty mind-blowing.
But 3D printing isn't perfect, right?
Of course not.
There are challenges too, like dealing with all that residual stress.
Yeah, residual stress is a big deal, especially with metals,
Yeah.
because you're building the part layer by layer,
Yeah.
The metal cools down and shrinks as it hardens,
Uh-huh.
and that can create stress inside the part, which makes it warp
Hmm.
or even crack. Kind of like, those fancy layered cakes.
Yeah, the ones with all the frosting.
Right. If you don't let each layer cool properly, the whole thing can, fall apart.
Oh, that's a good way to put it. So it's gotta be really careful with the cooling process in 3D printing too.
Yeah. Especially for important stuff like airplane parts or medical implants, you really don't want them cracking.
Right, definitely not.
And speaking of cracks, there's this paper with a really clever way to measure that stress. Instead of fancy equipment, they kept it simple. They 3D printed these steel bars. Then they made a cut partway down the side. The more the two halves sprung apart, the more stress was inside.
Clever.
Yeah, and this simple method tells you how to make the 3D printing process better.
So it's not just about the final product, it's about understanding the whole process.
Exactly. Once you know how much stress there is, you can tweak how you print to make the parts more stable and reliable.
So it's all connected, like how you print affects the final part. What about joining different materials? Like how do you stick something light and super strong like carbon fiber to, let's say, metal?
Good question. Researchers are using these things called anchors to do that.
Anchors, like boat anchors.
Not quite, haha. They're more like tiny little shapes that get embedded in both materials to make them stick together really well.
Huh. So instead of just gluing them, you're like weaving them together.
Kinda.
Yeah.
What's cool is they didn't just come up with one anchor design, they tested out 11 different ones using computer simulations.
Whoa, so it's like a virtual competition for the best anchor?
Exactly. They looked at the size and shape of the anchors and, like, how well they gripped onto the carbon fiber and metal.
Did they just like look at it with their eyes?
No, they use this technique called the cohesive zone model. It's like zooming way in to see how these tiny anchors hold everything together.
That's some serious attention to detail. And speaking of details, there's this other study that focuses on like fine-tuning the 3D printing process itself for this specific type of steel, 17 to 4 pH stainless steel. It's a mouthful.
Haha, it's a popular one for 3D printing, though.
So this research is about how all the little settings on the 3D printer can change how strong and tough the final product is.
Yeah. It's not just the material, it's how you print it, too. Kind of like even if you use the same ingredients for cookies.
You can get totally different results depending on the oven temperature and how long you bake them.
Exactly. These researchers used a method called the Taguchi method to figure out the best settings for the 3D printer.
So it's like finding the perfect recipe for the 3D printer?
Pretty much. And by controlling all those little variables, you can get super precise with the properties of the final product. It's amazing how much control you have with 3D printing.
It really is. And it's not all about making like super strong parts for cars or rockets. This next study shows how you can use 3D printing to restore like really old and delicate architecture stuff.
That one blew my mind.
I know, right? They focused on using PLA, which is, that biodegradable plastic we talked about earlier, to make copies of these architectural pieces that aren't just pretty to look at, but can actually hold up over time.
They really focused on the internal structure of the 3D printed pieces, like giving them a hidden skeleton for support. And they tested different designs, like reticular and rhomboidal.
So it's like designing the best support beams for a tiny building.
Kinda. They used computer simulations and real-world bending tests to see how strong each design was.
So they really put them to the test, huh?
They did. It's fascinating how 3D printing can bring together ancient architecture and cutting-edge technology.
It's like stepping back in time while still looking towards the future. But what about the environmental side of all this 3D printing? Can we make it more eco-friendly, especially with stuff like concrete, which isn't exactly known for being green?
That's a really important question, and researchers are exploring different ways to make 3D printing concrete more sustainable. One study looked at replacing some of the cement in 3D printed concrete with either biochar, it's like a charcoal-like material, or recycled fines, which is basically like dust from construction waste.
So it's like giving new life to materials that would ended up in a landfill.
Exactly.
Mm.
And they didn't just toss it in. They did all these tests to see how it affected the concrete, like how easy it was to work with, how long it took to harden, and of course, how strong it was in the end.
It sounds like they were super thorough.
They even used this fancy technique called isothermal calorimetry. It lets you track the heat released as the concrete hardens. It revealed some interesting differences between the biochar and the recycled fines.
So they're really digging deep to understand how these materials work.
Yeah. It's all about making 3D printing concrete more sustainable without sacrificing quality.
That's awesome. So 3D printing isn't just for making buildings and cars, it's also making a big impact in medicine. This last study we'll look at for part 1 is about 3D printed hip implants.
Hip implants.
Yeah, the ones made from that titanium alloy, Ti6Al4V.
Oh, right, the custom-made ones.
Exactly. But even with this, like, super advanced tech, there's still a chance that tiny cracks can form during the printing process.
Oh, that sounds like a problem.
Yeah, and they're like super tiny cracks.
So how do you even find them?
Right.
Is-
What if they cause trouble later on?
Good point.
Well, researchers are using these incredible computer simulations called MBD-FEM co-simulation to try and predict how these cracks might grow over time.
So it's like looking into the future of the implant.
Yeah, they actually created a virtual model of a hip implant with a crack and then simulated what would happen to it during normal walking, like the stress and strain and all that. And by using like the rules of fracture mechanics, they could tell if the crack was likely to grow slowly or if there was a risk of it like suddenly breaking.
It's like they're giving the implant a virtual stress test.
Exactly. And this kind of research could help make 3D printed implants even safer and more reliable in the long run.
It's amazing what we can do with computers these days.
Well, that's all for part one of our deep dive into the world of 3D printing.
We covered a lot.
We went from super strong plastics to 3D printed engine parts, historic buildings, eco-friendly concrete, and even hip implants.
It's incredible how much 3D printing is changing the world.
It really is, and we're just getting started. In part two, we'll delve even deeper into the challenges and opportunities of this rapidly evolving field, so stay tuned.
Can't wait. Welcome back to the deep dive.
You know, thinking back to all that amazing 3D printing stuff we talked about, I'm like especially curious about those super strong plastic plates, the ones with the graphene. It's crazy how just adding a little bit of graphene can make them so much stronger. But didn't the researchers find like a downside to that extra strength?
Yeah, you're right, they did. Adding the graphene made the PLA way stronger, but it also made it like less flexible, less ductile, I think they called it. Basically, it was more likely to just snap under stress instead of bending a little.
So it's like trading bendiness for strength, right? Could that be a problem?
It definitely depends on what you're using it for. Sometimes that extra strength is worth it, even if it's a bit more brittle, but sometimes you need that flexibility, so you got to think about the design and maybe even how you add the graphene to get the right balance.
It's like you always got to find the right recipe, her. And that makes me think about another challenge with 3D printing, like making sure every part you print is the same, especially when you're making a ton of them. If you're 3D printing hundreds or thousands of parts, you got to make sure they're all good, right?
Oh, absolutely. Consistency is key, especially in manufacturing. And that's where statistics come in. Remember that Taguchi method they used to fine-tune the properties of that 3D printed steel?
Yeah.
That's all about making sure things are consistent.
Right, but I'm still a little confused about how it works. Can you, like, break it down for me?
Sure. Imagine you have all these different knobs you can turn on the 3D printer, like the laser power, how fast it scans, stuff like that. The Taguchi methods is like a system for figuring out which combination of those settings will give you the best results and make sure every part you print is as good as the last one.
Ah, okay, so it's like instead of just messing around with the settings randomly, you have like a strategy for finding the best ones.
Exactly. It's all about optimizing the process so you get better quality and fewer like wonky parts, which is super important if you're making something like, airplane parts or car parts where everything needs to be perfect.
It's like having a foolproof recipe for 3D printing, so every batch comes out amazing. Speaking of recipes, remember how we talked about making 3D printing concrete more sustainable?
Yeah. Using those alternative materials like biochar and recycled fines.
Right. But did they like check to see if that eco-friendly concrete would actually last? What if it starts to like crumble or crack after a few years?
That's a super important point. Being eco-friendly doesn't mean much if it falls apart, right?
Mm.
Researchers are doing a bunch of tests to make sure these new concrete mixes are durable, like checking for shrinkage and water absorption, things that can really mess up concrete over time.
So they're not just making it green, they're making sure it can stand the test of time too.
Yep. They're comparing them to traditional concrete to see how they hold up in different situations.
Yeah. Makes sense. It reminds me of those 3D printed hip implants. Besides worrying about tiny cracks, I guess you also got to make sure the implant like actually fuses with the bone right.
Oh, for sure. That's crucial. You want the implant to be anchored in the bone, nice and secure for the long haul.
Right. So how does 3D printing help with that? How can it like encourage the bone to grow into the implant?
Well, it's all about the surface of the implant. With 3D printing, they can make really specific textures on the surface, like tiny grooves or pores that mimic the surface of real bone.
Huh.
This kind of tricks the bone cells into thinking the implant is part of the body, so they grow into it and create this super strong bond.
Wow. It's like the implant has like tiny little hooks that grab onto the bone.
That's a good way to picture it. And with 3D printing, they can control those surface features so precisely, they can make all sorts of crazy designs to find the ones that work the best.
It's like we're hacking the body's own repair system to make these implants work even better.
Pretty much. It's an awesome example of how 3D printing and our understanding of biology are coming together to create some truly amazing medical advancements.
Welcome back to the final part of our deep dive. It feels like we've gone through like a whole sci-fi movie with all this crazy 3D printing research.
Right. And we've barely scratched the surface. There's so much more to come. It's really exciting.
Okay, so give me a glimpse into the future. What's next for 3D printing?
Well, one thing that's getting a lot of attention is like totally new materials made just for 3D printing.
Oh.
Yeah, we talked about like tweaking PLA and steel, but now they're making materials from scratch that are like perfect for 3D printing.
So instead of trying to make the old stuff work, they're inventing brand new stuff.
Exactly. And these new materials could be super strong or super flexible or conduct electricity really well. They could even be self-healing. Can you imagine that?
Whoa, self-healing, like Wolverine.
Uh-huh. Kinda.
Yeah.
Imagine a 3D printed bridge that could, like, fix its own cracks.
That's insane.
I know, right?
Mm.
And another big thing is combining 3D printing with other, like, super advanced tech, stuff like AI and machine learning.
Okay, now that sounds seriously futuristic. How would, like, AI even work with 3D printing?
Well, imagine using AI to, like, make the whole 3D printing process way better, faster, more efficient,
Uh-huh.
AI could look at the design of a part and automatically tweak all the settings on the printer to get it just right.
Ah, okay.
Or it could even, like, watch the printing in real time and fix any problems before they even happen.
So it's like having a robot expert watching over your shoulder, making sure you don't mess up.
Haha, yeah. And as AI gets smarter, it'll open up even more crazy possibilities, like imagine printing custom medicine or building houses on demand.
Whoa, okay, slow down. That's a lot to take in. But all this stuff sounds kind of small scale. Could
Yeah.
we ever 3D print something really big? Like a house or a
So
bridge?
you're thinking about large-scale 3D
Yeah.
printing, right? It's already happening. There are 3D printers that can squirt out concrete or other building materials to make whole structures right on the spot.
No way.
Yeah, so instead of building things piece by piece, you could just, like, print out a whole building.
That would change everything.
It would. It could make construction way faster, cheaper, and better for the environment.
But wouldn't printing a whole house use a ton of energy? Wouldn't that be bad for the environment?
That's a good point, and it's something researchers are working on. They're developing new 3D printing tech that uses less energy, and they're looking into ways to power those printers with renewable energy,
Mm.
like solar and wind power.
Okay, that makes sense. So it's not just about making the tech work, it's about making it work in a way that's good for the planet.
Exactly. Sustainability is a huge part of the future of 3D printing. They're also working on reducing waste, like using recycled materials, and figuring out how to reuse the waste from one 3D printing job in another one, closing the loop.
So it's like 3D printing is forcing us to rethink how we make and use stuff, and that's pretty cool.
It's a total game changer. And as it gets easier and cheaper to 3D print things, it could really change the world. Let anyone create and invent new things, not just big companies.
Wow, it's mind-blowing to think about all the possibilities.
It is. It really is.
Well, thanks for taking me on this deep dive. It's been like a trip to the future and back.
My pleasure. It's always fun to explore the cutting edge of technology. Who knows what amazing things will be 3D printing in a few years.
I can't wait to find out. Thanks for listening, everyone. Thanks for listening, everyone.